Hi there, this is Dr. John, your physics and math professor, coming to you with an introduction to circular motion. We're going to be taking a look at a car here, a car that's going around a road. This road is not banked, it's flat like that. So it's going to obviously have a friction to keep the car from going off into the bushes here when it goes around the road. You've all experienced that when you take your car and you go around a curve, you feel a push to the outside. Well, what you're going to need to have, you're going to need to have a force that pulls you toward the center. And actually it pulls you toward this radius of curvature here. This radius of curvature, think of this as if you had a string tied here at this dot, this spot, and the string sort of went like this around this portion of the curve, this portion of a circle. That's why it's called the radius. Curvature is of the curve. This, for a road, it could be, if this is 75 is a very small radius of curvature, it could be several hundred meters as well if it's a very gradual bank. Obviously, the smaller the radius of curvature, the slower the bank, the slower the curve is, and the less stress you're going to have to be pushed to the outside. So here's how it works, sort of. If you're going in this direction, like you are right here, and this blue knot's here, and you say, I want to turn in that direction, what you're going to have to do is accelerate a little bit like that. What that's going to do is that's going to make you go sort of in that direction, which would be sort of one of these up here. And you're still going to have to accelerate in that direction to make you go here until you're eventually going straight this way. And if you notice, I'm not going to show you exactly all the numbers on this. I'll do another video on that sometime. It's a geometry problem, but you're actually always accelerating toward the center or toward the center of the radius of curvature. You're accelerating in this direction. How much is your acceleration? That's something that we've calculated in another place, but basically the acceleration you're going to require to get yourself around the curve like that is v squared over r. The velocity you're going squared divided by the radius of curvature. The bigger the velocity, the more acceleration you're going to make. That seems sort of obvious. And the larger a curve there is, larger a curve means less stress on your car. So that's going to be less acceleration. And the force that you're going to need to make in that direction or pull in that direction is just multiplying this times m. mv squared over r. Let me just erase something here quickly. So these are important equations that you're going to use over and over again. I'm just going to write them down right up here. Is equal to mv squared over r. Now, there's something quite important to remember about this. This is called the centripetal or the centripetal, meaning sort of like you're pedaling toward the center. It's you're pedaling in this direction. That helps me to remember. That helps some people to remember it as well. So sometimes we abbreviate this FC or AC, a little c there, meaning centripetal or centripetal. You can pronounce it either way. Now also, you'll also realize when you're going in a car and you're going around a curve like this, you feel a force in this direction. You feel like you're being pushed in that direction. That's the same thing as when you're in an elevator and the elevator is accelerating upwards, you're going to feel a force downward. That's almost like a fake gravity. It's an artificial gravity. Einstein actually said the gravity due to acceleration is the same as the gravity that we experience standing on the earth. It's the same basic principle. And so what you'll actually do is you'll be feeling an acceleration, a gravity in that direction. The value of that gravity or that acceleration is going to be equal to this. It's mv squared over r, or the acceleration, which is via the gravity units, v squared over r. Sometimes people call that the centrifugal force. I'll just write that up here. Centrifugal force. It acts away from the center. It pushes you in this direction. And it's sort of like, you may have heard of a centrifuge in science. They'll have these centrifuges where you put a little flask with some stuff in there, and then it'll spin around really, really fast. And the artificial gravity created there will separate things according to mass and according to density. Very, very important principle in science, pushing you outward. So the centrifugal force will push you out there, or seem to push you out there, which is going to be with the same amount here. mv squared over r, dealing with these same principles here. So you might say this one pushes you outward, this one pulls you inward. So what they're asking in this question is just simply, what force toward the center is going to be required to keep this car on the road as it goes around a curve? Since this road is not banked, that force is going to be caused by friction, a friction between the tires and the road. Will often have a little Greek letter M, which is spelled like that. It's like a U with a stick on that side there. Greek letter mu, which is the coefficient of friction between the tires and the road. We're not dealing with that in this question. We'll do that in the next question there. All they're asking for is, what is the force that is going to be needed in this direction to keep the car on the road? Well, that's just simply using this formula here. You'll be using the v squared over r. So let's plug these values in. 925 times v squared, 22 squared over 75. Let's do that on our calculator and see what answer we get. So here's the answer I got plugging this into my calculator, 5969.33. That's a really nice answer. Your calculator will give you lots of digits. But when you have the final answer to a problem like this, always look at the original question and see how many significant figures there are. This one has 3 significant figures, this one has 2, this one has 2. So you're going to write it as the one with the lower significant figure. In that case, it's 2. So you're going to have to round this up. Since you can't, there's nothing you can do with this 9. This is going to make this a 6. You're going to have to round this up to 6000. But this number here, if you write this number like this, 6,000, this only has 1 significant figure. So you're going to have to use scientific notation, which would be 6.0 times 10 to the 3. Now, these two numbers, the 6 and the 0, are both significant, and 10 to the 3 tells you how much it is. And what's the units for this? This would be in newtons. So there's the answer to this question, to 2 significant figures. I hope that helped. If it did, like and subscribe, and watch the next video. Bye-bye.